we were given y equals to minus 3x minus k over x minus p, and we were given one point coordinate b negative 1 over 3 0, and we were given t, which is a point of the asymptote. The point of the asymptote 1 and q. This is the asymptote, guys. A asymptote intercept where the asymptotes intercept. It's 1 and q. 1 represents p. All right. So the graph looks like that. This is negative 1. This is negative 1 over 3, because this is negative 1 over 3 and 0. Right? So this is point T, this point where the asymptotes intercept. So this point we want K and P. P we can find it because we know x minus P equals to 0, and x is the value of the asymptote, so 1. 1 minus P equals to 0. Therefore, P equals to 1. P equals to, sorry guys, this is negative. This is negative because it is this side. So this is negative here, negative there. So P equals to negative 1 because the asymptote is negative 1, not positive, it's negative 1. It's on the left side of that y-axis, right? So for K, we will say, we will substitute this coordinate there. So y is 0 equals to minus 3 into x is negative half, sorry, negative 1 over 3 minus k, and x minus p. So it doesn't matter whether I substitute p here or not at this point, because when we cross multiply, everything here is gonna be multiplied by 0. So you'll remain with 0 equals to this multiplied by that, get positive 1 minus k. Therefore, k equals to 1. So we have p and we have k, right? We have p and we have k. Number two, they want us to prove. They want us to prove, right? They want us to prove. So from what we found, we have minus 3x minus k. Our value of k is positive 1. So we're gonna write positive 1, and x minus the value of p is negative 1. Negative 1. There we go. So I substituted. So we'll proceed from here. X negative is positive 1. There we go. So from here, guys, the next step is to make sure that this part, the denominator, forms part of the numerator. Let us proceed on this side. Let us proceed on that side. So y is equals to, okay, then we're going to start by writing our denominator, because that one will not change. Remember, x minus p does not change. So now we need to have this term x plus 1 on the numerator. So where you see x on the numerator, we're going to represent it as x plus 1. So we had negative 3. I will take negative 3 outside, like that, an open bracket. Sorry. Okay, open bracket here. Then instead of writing x, I'm going to write x plus 1, because we need to have this also on the top part, x plus 1. There we go. But remember, the numerator, it was negative 3x, negative 1. So the constant is negative 1. So it means the constants here, when you add them, they should be negative 1. So we need, let's cross multiply and see. Sorry, let's multiply, expand this. If I try to expand that, I have this, and that gives me negative 3x, and this and that gives me negative 3. But this can't be true, because it has to be negative 1, not negative 3. So how can I make it negative 1? I have to do what? Add positive 2. Because negative 3 plus 2 will give us negative 1. See that, guys? So this will give us negative 1. So this becomes that, and this becomes this, then it is correct. So it means here I have to add positive 2. So here it is, guys. So now we have x plus 1 on the top as well. So once you have x plus 1 like that, once you have the denominator also on the numerator, you separate the terms. So y equals to So I'll separate, I'll write this -3 into x plus 1 over x plus 1, and there's a positive there, then we'll say plus second term 2 over x plus 1. Now we separated the terms. So from here, what do? We realize we have x plus 1, we have x plus 1. So this term cancels that term. What do we remain with? Remain with -3. So y equals to -3 plus this one, nothing happens here, 2 over x plus 1. There we go. So we can see this is q. This is the standard formula for hyperbola. This is q. Let's write q on the right side. So y equals to 2 over x plus 1 minus 3. This -3 comes from here by simplification. So this is the final answer. We proved the formula. We proved the formula. Remember, the question was for us to show that this can be simplified to that in the standard form. We write this equation in this way as a standard form. So from here we can see q is -3. So meaning when we go to the graph, q has to be at the negative side. And a is positive. If a is positive, it means we are going to use the first quadrant and the third quadrant. So let's check those on the graph. If they are right, we know we are fine, just for confirmation. Here's the graph. They used the first quadrant and the third quadrant. Remember, 1, 2, 3, 4. So they used the first quadrant and the third quadrant. So we are correct, A is positive. Now, Q was -3, which means the asymptote is on the negative side, which is correct because this is the negative side. The y values are negative here. So Q is -3 is correct. So we have proven that formula. We confirm that it is correct. So we are right and did it the right way. Remember guys, from here you want to force to have this term on the numerator. So you're gonna write, instead of x, you're gonna write x plus 1 or x whatever is here. You're gonna write it there, and then you're gonna expand and see which term is missing in order for you to have this balance. So -3 times 1 was -3. If we have -3 and we want to go to -1, what do? We add a +2. That's how this +2 came. So that this is the same as that, because it's the same thing. Then from there, we separate the terms. This term and this term, we separate them. And then from there, this has the same terms. We cancel out, remain with that constant, and then we simplify and write it in the standard form. That's it, guys.